Now we can test our Angular applications from scratch by writing and executing just pure simple JavaScript functions. And in those functions, we can create instances of the relevant classes, we can call functions, and then we can check the actual result versus the expected result. But since testing is such a common activity with JavaScript, there are a number of testing libraries and frameworks we can use which reduce the amount of time it takes to write tests. Two such tools and frameworks that are used when testing Angular is Jasmine and Karama, and a discussion of those is the topic of this lecture. By the end of this lecture, you're going to know what the Jasmine test framework is. You're going to know how to write tests in Jasmine. You're also going to know what the Karama test runner is. You're also going to know how to create and run tests using the Angular command line interface, and how to create and run tests in plunker. So Jasmine is a JavaScript testing framework that supports a software development practice called behavior-driven development, or BDD for short. Now it's a specific flavor of test-driven development, or TDD for short. Jasmine and BDD in general attempts to describe tests in a human-readable format, so that non-technical people can understand what is being tested. However, even if you are technical, reading tests in BDD format makes it a lot easier to understand what's going on. So for example, if we wanted to test a function like the one on the screen right now, just hello world, which just returns the string hello world, we would write a Jasmine test spec like this. So we have a describe function which defines what we call a test suite, which is a collection of individual test specs. The it function defines an individual test spec, and a test spec contains one or more test expectations. So the expect function is what we call an expectation. So in conjunction with a matcher, it describes an expected piece of behavior in the application. So this last piece of code here is what we call a matcher expression. And this one does a Boolean comparison between the actual value passed into the expect function and the expected value passed into the matcher function. So we are saying that we expect the hello world, the result of calling the hello world function, to result in a string which is hello world exclamation mark. And the first parameter to usually each of these functions is just a textual description. And when the results are printed out on the screen, it almost reads as if a human being is reading it. So we're describing a set of tests around hello world. The specific test spec is just testing that it says hello. And then we actually call the function and we have the expectation here. Now Jasmine comes with a number of pre-built matches, which you can find from the official Jasmine documentation. So we can have the to be matcher, not to be matcher, to equal. We can match a regular expression. It can be a defined or an undefined value. It can be null. It can be something that eventually resolves to a truth value or a false, or it can contain, an array can contain a value. We can have a number of different matches that we can use. Now sometimes in order to test a feature, we need to perform some setup. Perhaps it's creating some test objects or something else. Also, we may need to perform some cleanup activities after we have finished testing. Perhaps we need to delete some files from the hard drive, or again something else. Now these activities are called setup and teardown. Teardown is for cleaning up. And Jasmine has a few functions we can use to make this easier. Now we have the before all function. This function is called once before all the specs in a describe are run. We have another one called after all, and this function is called once all the specs have finished running. We have before each, and this function is called before each test specification has been run. So before each it function is run. And then we have after each, which is called after each test spec, each it function has been run. And so with our simple example here, we might use these functions in this way. So I might add the before each function in the body of my describe function. We pass into the before each function a function which it will call before each of the test specs are run. And inside the body of my before each function, I might set up some information. In this example, I'm just setting up some data in a variable called expected. And the same goes for the after each function. I might use it just to clean up some information. And just to complete it off, I'm going to use the expected variable in our test spec. So when it comes to running Jasmine specs, there's a couple of different ways. To manually run Jasmine tests, we would create a HTML file and include all the required Jasmine JavaScript and CSS files. That's what I've done here. So if we go into the index file, you can see in terms of JavaScript, I've included the Jasmine JavaScript library, the Jasmine HTML JavaScript library, another file from JavaScript called boot.js. I've then included all of our code. So I've included both the actual code, the main.js is where the code that we want to test lives, so the hello world function, and the test.js is where our test code lives. And at the same time, I've included some CSS files from the Jasmine framework, just to pretty up the presentation. Now, just a quick note, the order of the script tags is very, very important. They need to be in this order. And also we need to make sure that we include the code that's going to be tested before we include the test code. Now to run these tests, we simply open up the HTML file in a browser, or since we're running in plunker, we just need to run the plunker. Now once all the files via the script and link tags are loaded by the browser, the function window on load is called, and this is when Jasmine actually runs the tests. So Jasmine only runs the tests once all of the files have been loaded in the browser. So to run this, in plunker at least, I simply run the file. And you can see on the right hand side, these are the results of the Jasmine test run. It's passing, so everything's green. If I was to go back into my test file, and let's change this so it fails. I'm going to change the expected to something else. Let's rerun. And this is now what you see if Jasmine fails. So not only do you see that it failed, it also gives you just a helpful error message, which you can use to help figure out what went wrong. So it's not so easy to do in plunker, but if running within a browser interface, it's actually quite easy to debug your Jasmine application. So I'm just going to run this same test, but running it locally from within a browser, running locally on my computer. Here we go. This is the passing test case. So now if I inspect, if I go to sources, open up my test file, I can easily figure out what's going on. If there's a problem with the test, just by dropping a breakpoint in somewhere and just refreshing the page, and it will pause at this breakpoint, and at this point I can just step over and figure out what's going on. So if you have a failure test case, this is what you do to figure out what's wrong with your code and what you need to change in order to fix it. So that's how you can run. So this is how you can run and debug your test in the Chrome browser. But if you needed to run your tests in different browsers, all you need to do is open up a Safari or a Firefox or an IE and just load up the Jasmine test HTML file in that browser to see how your code behaves in different browsers. So manually running Jasmine tests by refreshing a browser tab in different browsers every time we edit some code can become really tiresome. Karama is a tool which lets us spawn browsers and run Jasmine tests inside of them, all from the command line. The results of those tests are also displayed on the command line as well. Karama can also watch your development files for changes and rerun the tests automatically. And the point of Karama is that it lets us run Jasmine tests as part of a development toolchain which requires tests to be runnable and results inspectable via the command line. So for instance, if you're using gulp in your project or grunt or some sort of command line interface to run and compile and execute their files, Karama lets us run tests from within that script file. Now, it's not actually necessary to know the internals of how Karama works. Just know that when using the Angular command line interface, it handles the configuration for us and uses Karama to actually run the tests. I'm going to quickly show you how to use the Angular CLI in order to create and run tests. But for the rest of this section, we're actually going to be running tests only using Jasmine via plunker. That's again for similar reasons as we've been using plunker in the past. So I can pass you a link which you can play around with, edit, and if you have any problems, you can share that link back to me or ask for help from others. It's much more difficult to do that with a full-blown project created using the Angular CLI. So when creating Angular projects using the Angular command line interface, it defaults to creating and running unit tests using Jasmine and Karama. Now in front of you right now is the project that we created in the section on the Angular CLI. So whenever we created files using the CLI, as well as creating the main code files, it also created a simple Jasmine test spec file, named the same as the main code file, but ending in .spec.ts. So for example, when we created the pipe, mypipe.ts, this is the stub code it created for the pipe, but then next to it, it also created a test spec file for the pipe as well. And you can see it's got a describe function, an if function, and an expectation. Now the actual code, the actual test code that gets bootstrapped depends on the type of thing that we're creating. So this is what gets bootstrapped for a pipe. If we now look at a service, you can see we have a slightly different thing that gets bootstrapped. And for a component, we have something a bit different as well. Now with the Angular CLI, in order to run all the tests in our application, we simply type ng test. This runs all the tests in our project using Jasmine via the Karama command line runner. So it watches for changes to our development files, bundles all of the developer files together, and then reruns all of our tests automatically for us. So when building a real Angular application, I recommend that you stick to the file and folder structure defined by the Angular command line interface. And also use the built-in test runner framework that is configured by the Angular CLI. However, for this section, and to give you an easy way to view and play with code, we are going to use only Jasmine and execute tests by refreshing a browser. This is so we can easily share code via a plunker like we've done for the rest of the sections in this course. Now an Angular Jasmine plunker looks very similar to a normal Jasmine plunker, apart from a few key differences. So this is an Angular Jasmine plunker, and you can see, as well as including in the Jasmine required files, we're also including in some files that we need in order to run Angular. So we've got the reflect metadata file, we've got various zone files, and we've got system.js at the top here. And then underneath, we add the specific spec files that we want to test into a special array variable called spec files. And then right at the end, we load this file called browser-test-shim.js. And this is the file that triggers running the test specs once we have finished transpiling and then loading the transpiled files in the browser. So very, very close to a typical Jasmine HTML file, but with just a few key differences to make it work better with Angular. And finally, I'm just going to talk about disabled and focused tests. So you can disable tests without commenting them out just by prepending X to the describe or it functions. So if I just prepend it with X, and then let's try and rerun this test, you can see it's just saying this temporary disabled with XIT. So it doesn't fail it, the tests aren't failing, it's just saying, hey, I'm not going to run this particular test. And you can do the same just by putting an X in front of describe. So as you can see there, it's also yellow because it's disabled. And that's how we can disable some tests. The opposite of this is we can focus on specific tests. So let me take the X off. And let me create two test specs. This one called 1.1 and the other one 2. And let's say I'm just coding on the second spec right now. I just want to focus on that one. So I can just put an F in front of it. And now when I rerun the tests, oh, it's actually a failure case. Let me rerun it with a passing case so you can see it running fine. And then you can see it's not actually run the first test case because we're not focusing on it. It's only running the second one because I say I want to focus on that one right now. So to summarize, Jasmine is a testing framework that supports behavior-driven development. We write tests in test suites, which are composed of one or more test specs, which themselves are composed of one or more test expectations. Now we can run Jasmine tests in a browser ourselves by setting up and loading a HTML file, but more commonly we use a command line tool called Karama. Karama handles the process of creating the HTML files, opening browsers, and running tests, and returning the results of those tests to the command line. Now, if you use the Angular command line interface to manage your projects, it automatically creates stub Jasmine spec files for you when generating code. Now, it also handles the Karama configuration, the transpilation and bundling of your files. So all you need to do in order to run your tests is type the command ng-test. But for the purposes of this section, we will be using a simple browser-based Jasmine test runner so we can share the code easily via plunker.